Good evening, everyone present here. On behalf of Symbiosis Institute of Operations Management, Nasik, we welcome all participants, researchers, students, and the guest speaker to the 8th webisode of Editor's Choice. It's a platform for illumination by leading editors from various journals of international repute. Together, let's expedite the exchange of ideas and scaling up exemplary practices in the research domain. Being the moderator of the 8th episode, I would like to share an interesting sign of the number 8 in the numerology that intrigued me. Number 8 is a symbol of infinity and a constant flow of energy and power. An achiever who measures life by the goals it reaches, and for every blessings it receives, puts one back to the universe. It's unquestionable that when things are balanced, they are feel stable, controlled, and supported, and thus creates the most productive environment. In my opinion, a researcher is like the numerology number 8. They make a huge strides in advancing essential knowledge. Their achievements can save lives, can change the way we understand the world, and improve the quality of life we live. However, in publishing, one research paper can be long, winding, and might wander off in the wrong direction. So to discuss today, the editor's choice has a topic been picked up as from research to publication and some personal experiences. Today we have with us Chair Professor from the City University of Hong Kong, Professor Min Xie. When Rumi, a 13th century Sufi poet, penned down these lines, that the nature of reality is this: it's hidden, and it is hidden. And so aptly related to the research world. We researchers, authors, academicians believe in the quote engraved by Stephen Pressfield, who states that writers think in metaphors, editors work in metaphors, and readers read in metaphors. Who amongst us wouldn't seek a guidance for writing and publishing some good research papers? This 8th webisode is on the very much such thoughts and the challenges we researchers go through. So without any further delay, allow me to introduce you our expert for the 8th webisode, Chair Professor of Industrial Engineering, Min Xie from the City University of Hong Kong. Professor Xie received his PhD in Quality Technology from the Linköping University, Sweden in 1987. A licensate holder in the Reliability and Maintenance Engineering from the very same university, Sweden in 1986. He did his undergraduate study from the Royal Institute of Technology in Sweden and was graduated in Masters in Science in Engineering Physics in 1984. He joined the National University of Singapore in 1991 and was one of the first recipients of the prestigious Lee Kuan Yew Research Fellowship Award. In May 2011, Professor Xie moved to the City University of Hong Kong as a chair professor in industrial engineering. Professor Xie has published over 300 journals and 8 books, including Software Reliability Modeling by the World Scientific, Statistical Model and Control Charts of High-Yield Processes by Springer, Advanced QFT Applications by Will. He is an editor, associate editor, and an editorial board of 20 established international journals. In particular, he is an editor of Reliability Engineering and System Safety Department of Editor of IISE Transactions, area editor of Computers and Industrial Engineering, and a past chief editor of Quality Technology and Quantity Management, to name a few amongst. Professor Xie was elected Fellow IEEE in 2005, and he started influential IEEE international conferences on industrial engineering and engineering management. He has chaired many international conferences and has given some few keynote speeches to many others. Over 50 PhD students have been graduated under his direct supervision, and many are presently the faculty members at various universities in US, UK, Australia, China, and other countries. His research areas lies in reliability engineering, quality management, software reliability, applied statistics, and education. We will be running a Q&A at the end of the webinar. So we have enabled ask a question in the chat box. You can pen down whatever questions you have when Professor Xie is addressing us. With this, I now request Professor Xie to deliver his session. Over to you, sir.
Thank you very much for the kind introduction. In fact, I prepared a short introduction of myself that could be relevant to the audience and put into the context of my talk. Let me first share the screen. Oh, let's see. So you can see
yes.
my screen, right?
Yes, sir. Yes, sir. Yes.
I need to change back to the slideshow so that I can change the slide. Yeah. Just now, I actually closed the slideshow. So again, thank you very much for inviting me to give a presentation at the Editor's Choice series. This is a very well organized event, and especially very useful at this time when we cannot travel. In fact, I would have loved to visit your campus and meet with you to actually deliver a talk on campus. I have visited India many times. In fact, almost every year I try to count since 1995. So in fact, just last year in January, before the COVID-19 outbreak, I was in Bangalore for a few days. So I really hope that we will be able to travel again and we can meet somewhere. I also listened to some interesting talks by the earlier speakers, and they are really difficult to match. I will try my best to share some of my experiences. I have prepared some slides from other talks that I gave before, and hopefully the audience will find the things interesting and beneficial. So before I start, let me introduce my background a little bit more. I entered the university actually at the age of 14 in China, University of Science and Technology of China. But I was there for just a year before I got a scholarship to study in Sweden, Royal Institute of Technology. And I was in the Department of Engineering Physics, but I was interested in mathematics. So I took all the courses in mathematics and specialized and did my final thesis in applied mathematics. So I always tell people I learned mathematics in physics department. And then I continue with my graduate study, a PhD at the same university in probability and statistics. But just after a year, my supervisor decided to leave the university. So he introduced me to another professor at the Linköping University, because at that time, I became interested in applying probability and statistics in quality and reliability engineering. And I was the first professor in quality and reliability in Sweden or in the whole Scandinavia at Linköping University. So I moved there and finished my PhD, and I continue to work there for a few years before I moved to National University of Singapore. Now, when I was doing my PhD, the professor was actually at mechanical engineering department, because in mechanical engineering, there are a lot of equipment, facilities, and so on that they have to deal with and make sure that things are reliable of high quality. So I was in mechanical engineering department, but people in the department had more problem with the software. For example, if you build a robot, okay, it's very easy, not too difficult. But to write computer code to control the robot, it's very difficult. And they also had a lot of CAD/CAM system to use computer-aided system to help to design the aircraft and cars and so on. So for mechanical engineering professors and students to write computer code and to test computer code, it was very difficult and headache for them. So I was actually encouraged or asked to work on reliability of software. So I did my research on software reliability when I was at mechanical engineering department. Okay, so after that, I moved to National University of Singapore. In the middle, you see just one line, but it is a span of 20 years. So I have been with City University of Hong Kong for 10 years. Now, the other thing is I have been in industrial engineering department in NUS and also CTU. And being in this type of department, we can work with people from very different backgrounds. So in fact, my PhD students also come from very diverse background. So we work on different types of problems and publish a number of papers. And then I also got invited to join our various editorial board and be appointed as associate editor and so on. I always try to help. I don't know how to say no when they ask me to review paper, to handle the submission. So I'm getting a lot of papers to handle and to review. So sometimes I tell people that I don't know whether this is a kind of reward or penalty when they are giving more things to do. On the other hand, the paper that I published appeared in many different journals. So this was a search that I did last week from Web of Science. So I have published paper in all these journals. This is the truncated list. There are more journals listed below here. Of course, we know the Pareto principle. In some journals, I have more papers. For example, here, 25, 29. But in many others, I only have 1 or 2 papers. As I said, I did my research when I was reading on software reliability. How I did that is also interesting and useful for students. So basically, it was a new area at that time. Although I did not have the background, I tried to go to the library to find all the relevant articles, and especially those important ones, and read those papers. And I read those papers critically. Of course, I could not be too critical at that time, but when you read a paper, there will be authors commenting on earlier works, and they usually have to be a little bit more critical to support their research in that direction. So I found some interesting gaps and continue to do my research to try to fill those gaps. And sometimes I also try to extend others' results. So that's how I published a few papers on software reliability models. And after that, I got an invitation to write a book on software reliability modeling. Now, this book has been around for almost 30 years, but it's still widely cited because it summarizes the software reliability models, especially the simple ones that are more useful in this book. There are a lot of research that people have done after that. So to my students, I always tell them that, okay, you read this type of things as introduction, but you really need to read the most recent papers on this topic so that you know what people have done after that, and then try to identify some gaps to fill and to continue with the research. So that was how I did my research on software reliability. And that is something that I think students can also do when you start doing your research. Now, quality control and quality management was actually something that I did after I moved to National University of Singapore. Now, when we teach, we have to teach a lot of basic contents and get the students to work on some projects and so on. So we are talking about undergraduate students and Master of Science students by coursework, not those research students. I always think that when we teach something, we should also try to use the tools and techniques ourselves. So we actually try to use different types of quality control and management tools and techniques. And we realize that there are a lot of problems and issues. So we actually continue and conducted research on this topic. One example is there are a lot of control charts in the company, but when you have a high quality process, you don't observe many defects. So traditional control charts will be meaningless. So we actually developed some new types of control charts and carry out studies on the properties and so on. We also try to use QFD technique, which is the method to convert customer needs and requirements to technical specifications. So we try to use these things ourselves. And then we realize that, oh, people draw up a household quality, use QFD and display, and that's the end. So we thought that we could do more and develop some optimization model, help people to allocate the resources, and publish a number of papers. And then we wrote a book on advanced QFD application. So this is another type of method to initiate and do research that we can consider, especially for new research students. Okay, I see that someone could draw on my screen. I didn't, I'm not sure how to get rid of that. But anyway, I hope that you can see the slides. There are many other things that I did, and I will not talk about those things. Now, I thought to share this with you, my first problem as a student. So when I first started doing my research as a graduate student, I was actually given a problem by the professor who got a problem from a company. So basically, the company want to estimate the warranty cost when they provide free replacement to the customer. So if you have a car and the car breaks down, and then you give the customer free replacement, and then if it breaks down again within the warranty period, you replace it again. So the company, of course, want to estimate the warranty cost, but the warranty cost can basically be calculated as the expected number of failures during the warranty time, 0 to t, multiplied by the cost. So the whole failure process can be modeled by the so-called renewal process. So for those not familiar with the renewal process, you should be familiar with the Poisson process. So for Poisson process, we have time between events following exponential distribution. But in reliability, we know that the time between events will not follow exponential distribution, because if you make that assumption, you assume that the item or system will not age over time. Old one is the same as a new one. So exponential distribution has no memory, as we know. But what happens if we do not have exponential distribution for the time between events, but we have other distribution? Then the process is called renewal process. Without going to the details and theory, so we wanted to compute the expected number of events or failures up to time t, so from 0 to t. So what we need to do is to solve this renewal integral equation. So mt is the expected number of events that we are interested in. This ft is the distribution of time between events. It may not be exponential. We usually use Weibull and log normal and other distributions. So here we have the density function, which is derivative of the distribution function. So this equation is actually quite simple. So we could write a computer program to solve this. The first thing we need to do is to integrate this, and what we can do is to divide the x-axis into a number of intervals and use the width multiplied by the height and then add up the areas. So when we reduce the width this will convert to the true value of the integral. That is the area under this curve. It's not too difficult to write the program to do that, but the problem we faced was this: very slow convergence, and sometimes it does not converge. This is because we may have singularity, which means that fx may take value infinity. So when you try to do this, you basically use 0 times infinity, and the convergence was a problem. So I went to talk to people in mathematics because the renewal theory is a kind of a probability theory. It uses a lot of mathematics and a lot of research as results on that. When I talk to them, they say that, oh, this is well-known problem. It is a kind of, there's a name called the Volterra integral equation. Because of singularity, it causes problem. And for certain special function, they can get closed form solution. I say that no, that does not help because we may have general function, and we may even have empirical distribution function with a lot of infinity value if you convert to the density function. Then I saw that we wanted to use the numerical method. We don't need the theory. We just need a program that the company can use to compute this. So I went to talk to people in computer science department. There are people doing numerical analysis, developing numerical algorithms. Then they say that, oh, this is a hard problem. What we can do is to use some advanced method, such as finite element methods. We can use different types of approximation, truncated, or polynomial function, and so on. Then I saw that this is a simple problem. The company just needs a simple solution. Why we need to, use very sophisticated methods? In fact, those methods may not always work, and it's very slow. So I actually almost give up. And this is also one of the reasons why I studied software reliability, because I have the experience that existing subroutines and programs are not reliable when solving this type of equation. But one day, I saw that what is this fx? Density function, as we know, is the derivative of the distribution function, right? So this fx dx can be written as dfx. So this distribution function has no singularity, and it's actually very nice. It goes from 0 to 1, and it's monotone increasing. So from this equation, I rewrote it as this equation, and we discretize the integral, which is very easy to compute. And we got a set of linear equations, and we solve the linear equation system. And the result is surprisingly fast when I compare with other methods. It's much simpler than those advanced methods given to me by computer science people. And more importantly, it's very accurate because of the nice property of the distribution function. we do not even need a small step length. So we give the program to the company and the company pay to the university. But what's the benefit to me? I need to write this up and publish it. And I did write a paper. But this is a story. I had a lot of difficulty publishing this paper. First, I submitted to some applied mathematics journal because there are papers on this problem. So I submitted to one paper, one journal, it got rejected, submitted to another one, it got rejected. Then I noticed that the reviewer and editor felt that there's very little contribution to mathematics. I did not provide any mathematical analysis. So one reviewer asked, okay, are you sure your method converts? I said, I tried almost everything and there's no problem. Why you ask this question? And then some reviewer said that, can you show us the error bound, the lower bound and upper bound for the error? We did not do that. Then I saw that, oh, it's not suitable for this type of journal. Let's try the computer science journal. There are journals on numerical methods, algorithm. And my method is really good. People I talk to with this type of problem, they all like it. And then my paper was rejected. There was one reviewer who said in one sentence, I don't believe it's true. So you can imagine how sad I was. But luckily, I got a letter from my editor saying that there was another professor who read my technical report that we prepared and saw that this is very useful. And he asked whether I could let him publish my paper. So without submitting the paper to the journal, I got the letter from the editor. But of course, I say yes, if you think this is relevant for the journal, because I did not do any statistical analysis. But he said that, oh, this is about simulation and computation, so it's very relevant. So the paper, after being rejected by a number of journals, appeared in 1989, and it was published very quickly. Okay, so I had a few years, difficulty getting this paper published before that. Now, I did not continue to work on this problem. Okay, there are some messages in the chat, but never mind. Okay, so I did not work on this problem. But 10 years afterwards, I met a professor at IEEE conference. And we were sitting together and chatting. And then he suddenly asked, are you the Min Xie who wrote a paper solving the renewal integral equation? I was very surprised and said, yes, but why you got to know that paper? You are not in computer science, you are not in probability statistics. He said that, oh, in electrical engineering, we had similar problem, but we used MATLAB. And my student found a paper, found a program citing a paper. Then I was curious. I went inside, these are the links, and found this program. So in the middle, you only see a few lines, and this is the main part of the program. And the paper was included in a book, An Introduction to Stochastic Processes, that has a number of computer programs that are included in the MATLAB Central file exchange. So I usually share this with my students that they need to learn different things. They need to think about different ways to solve a problem, and knowledge from a different field can be very useful. And software packages, subroutines, etc., are not always very reliable. And as I said, this is how I got into interested in software reliability. Actually, this is not the end of this story. At that time, when my paper got rejected, I was certainly very sad. But now when I serve in many journal editorial board and as a reviewer and editor, we receive many papers like this. And after reading the paper, no matter how good they are, I had to reject them. The main problem is the relevance. So as I said, the paper was rejected by Applied Mathematics Journal because we did not really contribute to mathematics. We did not derive the convergence rate, error bounds, and so on. So it's not suitable for those journals. But how about the other types of journal? Numerical analysis, computer programming journal. And the reviewer said that I don't believe it's true. In fact, now I actually recently reflected on this and saw that, it's really true that it is not always correct. So what I mean is the reviewer was correct because when they develop algorithm, they are trying to solve the general type of equation, not the special type of renewal equation. And what's special with this? We know the distribution density function relationship. And we know that the distribution function is smooth. If you have a general function fx, you may not be able to write it in this way. So the method is suitable for solving renewal integral equation, but it's not always applicable to solve the Volterra integral equation that they were studying. So it's also not very relevant. But in the field of applied probability and statistics, this is actually very relevant. We know the distribution function very often, and the density function is a derivative of the distribution function. In some cases, especially when we use a Weibull distribution, to get the density function, we actually need to take derivative of distribution function, which in my case, it's not necessary at all. Okay, I just got the chat window open. Okay, this is how I got into software reliability. But why I select this topic to share with you, this was something that I did 30 years ago. This is also because software will become even more important today. So when people are doing research and development in artificial intelligence, I have many friends working in that area, and many of them are working on computational methods, algorithm. I always tell them that you need to convert things into the code. That is software. And we need to study the reliability of software. In fact, this was what happened in Hong Kong mass transit rail system a couple of years ago. And companies always try to upgrade the system. Same for the software. So they were replacing the old signaling software with more artificial intelligence software. But when they tested the software, the two trains collided. Luckily, they did the test after midnight when trains were not running with and no passenger injured. But this actually happened in the busiest tunnel in Hong Kong. And it took them a few days to remove or move away the train. So the economic cost is significant. And the other thing is, other example is, we know the Boeing 737 MAX, there are a lot of software, and the softwares are not really always reliable. And of course, the problem was caused by the sensor. But why they installed the sensor? Because they need to collect data, to use algorithms to control the aircraft. So the software did not really detect abnormal sensor reading. And the worst was the pilot could not control the software, the airplane. So there are many relevant issues, and software is actually just one part. So just now I say that, we need to convert the algorithms into software. And I've been working in software reliability for many years. And sometimes I also tell people software is useless unless it works together with hardware. So all these things should be linked together. So how to determine reliability of software? We have a system, we have hardware and software. So to the consumers, we only care about the reliability of system. So I will not go into the details, and if you are interested, there are a couple of books. Some years ago, we also wrote a book on computing system reliability. Okay, let me see. Please just give me some more minutes to share a few more thoughts about the publishing paper. Okay, so publishing is actually not easy, and we need to be patient. And the most important is we have to do good research to generate new and useful results. And if you get a paper to review, do help, because most people see the paper published, but they don't see paper rejected. So as a reviewer, as an editor, we see many papers that are rejected. Okay, so we actually learn more from failures. So that's why I shared my experience, not as a success story, more like a failure story. And how to get a research idea, try to read more and read things critically and try to improve the existing models and results. Okay, I will not spend too much time on this, and some earlier speakers already mentioned this type of thing. Also, after you have finished, done the research and try to write the paper, so which journal to submit to? As I try to share, we need to select the most relevant journal, and that will actually save everybody's time. The editor can easily find the reviewer, and the reviewer will be happy to read the paper no matter whether it is good or not, because it's very relevant to reviewers' research field, and you will get feedback and result quickly. And we also need to compare the contribution and contents and also the writing style with some of the recently published paper in the journal before we submit to that journal. Now, when we evaluate a manuscript, there are many factors affecting the decision or recommendation. The most important is the significance of the results compared to other published works in the same journal. But there are many other quality factors. The organization of the journal, writing of the paper, make it easy for the readers to, for the reviewer to read. Sometimes the formatting and layout and language, these affect the opinion of the editor or reviewer. So if we are lazy formatting the paper, there are many mistakes, overlapping graphs, then how can we trust your calculation, your results in other places? And for the language, I have many students, and to them English is not their first language. I always tell them, okay, try to use simple sentences. And we also have authors from India, and the English is very good. On the other hand, sentences can be very long, and paragraph can be very long. And in fact, many reviewers and readers, okay, they don't have English as a first language. So we also need to think about them, make it easier for them to understand, to appreciate the research results and contribution. It's not for them to learn English. Although I do ask many of my students to read papers by Indian authors because they do learn a lot. Now, when a paper is rejected, some authors like to complain, or most of us feel sad, but there's no need to do so. In fact, most papers are rejected. So we can actually try to see how we can improve the paper. So if you have a paper, submit to a journal and it got very quick accept, that may not be good, because you could probably have submitted the paper to a better journal. Now, when the paper is rejected, the first thing to do is to revise and improve, unless there is a problem with the relevance. But even in that case, when you submit to a different journal, you need to make some modification to make it more relevant to that journal. Okay, so you correct the problem and submit to a different journal. This is what we do very often. On the other hand, if you feel that the comments from the reviewers can be dealt with, and you can do some further research to add a section or some more useful results, you can always resubmit to the same journal. So I always encourage the authors to do, because I think that to any journal, we also do not waste the reviewer resource. So if reviewers have provided useful comments and rejected the paper, but if you can really extend, we really want to publish the paper, to also utilize the comments from the reviewer. I think other speakers also mentioned this, but I always want to have this as a reminder to students. This may not just affect you if something happened. This professor, the university reputation will suffer. So be careful with this and rewrite sentences if you are talking about the same thing and cite the references. That's very important. But in the paper, make sure that you have new and significant contribution in addition to what people did or know before. And these are some of the journals I'm heavily involved in. The red ones, I serve as editor handling a lot of papers, and others I got assigned papers by the chief editor, and there are many other journals that I help review papers. And we also started a conference 12, 13 years ago, International Conference on Industrial Engineering and Engineering Management. In fact, from the first run of this conference, we organized Meet the Editors panel. So we invite editors from different journals to share their views and suggestions to the audience. Okay, so this is from 1 year, and this is from another year. Okay, so this year the conference will be in December in Singapore, and hope that people can travel. And if the COVID-19 problem remain, we may have a mixed mode type of conference. Okay, so that's all I have prepared to share with you. And I'm to be happy to take some questions. But before that, let me just make another announcement. In fact, I have supervised many students, and we are constantly recruiting more students. And we provide the scholarships for PhD students. There are many different kinds of scholarships that students can apply. And this is a very prestigious fellowship by Hong Kong government. So Hong Kong PhD Fellowship. The stipend is actually over $40,000 US a year. Okay, so but it's very competitive, and students with good academic results and some research experience, hopefully some good publication already, will have a better chance. So I would like to encourage professors to recommend good students to us, and we can work together through the students. And students are also welcome to apply and contact me by sending CV. So again, thank you very much for listening, and let's see how we can proceed with the question and answer session. Thank you.
So thanks for your attention, all participants. Now, as we have started accepting the questions from the audience, you can either raise your hands or you still can put up the questions in the chat box.
SOM, one question is in the chat box from Debar.
I'm picking it up. I'm picking it up, sir. So as we have already received a few of the questions, and one of the questions is in the chat box, I'll take it up. Professor Sheel, this is the question from Debarkrita Roy.
So I can try to take it. The question is, how should I analyze results and the methodologies to use in my research paper? So again, it is important to refer to relevant journal doing publishing papers on similar topics. Okay, so sometimes you need to do the quantitative analysis, and sometimes qualitative analysis might be sufficient, but it really depends on the type of journal.
Thank you so much, sir, for the reply. Thank you so much.
Yeah, you're welcome.
Professor, there's another question, that how crucial, this has been the question given to us when the attendee had registered for this episode. The question is, how crucial role does the data analysis and scientific tools for aiding exploratory data analysis plays in a research project?
I'm not an expert on that, but again, my answer might be the same as what I said. So it really depends on the type of research and the type of journal. I do see another question from the participant who sent in the question earlier that I probably can talk a little bit more about. So now the question is, how can we approach the literature review paper writing?
Yeah.
Okay, so I think that I always ask my students to carry out extensive literature search and prepare a literature review, because that will be needed in the paper that student will write at the end. But I normally do not encourage students to write a review paper, because in a good review paper, it's not just to tabulate the paper, group the paper, counting the number, but it is important to provide insights and suggestions. And I think to the reader, critical review will be more useful. So others can actually read those papers and try to see what type of research that can be done to extend the research that are published. So again, reviewing literature is always very important. But unless in some special cases when the student can get the very good expert help, a review paper is not likely to be accepted by good journal.
There is another question from Aditi Chauhan in the chat box, Professor Xie, that what are the key aspects to keep in mind while researching for a certain field, for example, machine learning, while carrying out an empirical research model?
So I think this is the question that we actually answered before, but again, okay, so there are two things. One is the methodology. The other is the application domain. So I have published paper in different journals because sometimes it's a reliability problem of a piece of equipment, mechanical system part. So I cannot publish this type of paper in computer science software journal. And sometimes we have a problem with microelectronics because in Singapore, the industry is very important, and we have many students from electronics industry. So they were interested in quality engineering and quality management issues. So when you have that type of specific domain related research, then the papers have to go to those type of journals. So it also there are two things. One is the methodology, whether it's mathematical, whether it's empirical, whether it's other type of simulation study or so on. So this will help you to find the journal, but also the domain that the research is being conducted is also very important.
I'm much obliged to you, Professor Xie, for your remarkable session on few issues of publishing in international journals, starting from doing what is good and useful research. An example of safety and reliability of AI systems and how the management of those systems can, affect our daily lives. I think you also shared with us that software packages, subroutines, and algorithms are still not reliable. Don't be dismayed by the opinions of editors or critics. They are the only traffic cops of the arts. So, as cited by Jenny Flaw, that's all I can sum up to the interactions what we have done in this 8th episode, Professor. As we now approach to the end of this very episode, I request Dr. Arun Kumar to propose a vote of thanks for this.
Thank you.
So on behalf of SIOM, I take this opportunity to thank all those who have directly and indirectly contributed to this webisode 8 of Editor's Choice organized by our institute. At the outset, I thank our speaker, Professor Min Xie. We are really enlightened with your knowledge and presence. We are thankful to our director, Professor Vandana Sonmane, for her motivation and continuous support to make this episode come to reality. Special thanks to the research committee, faculty, and staff for their unflinching support and coordination. Our heartfelt thanks to all participants who are connected virtually with us. Before ending today's episode, I would like to announce the speaker for next episode, that is episode 9. Professor Gary Graham is the associate professor at the University of Leeds. Professor Gary Graham is associate editor, International Journal of Operations and Production Management. With this, we move to the end of today's episode. Thank you. Thank you, Professor Min Xie, for joining with us. So we will be in touch with you. So I need to learn more about the advanced QFT process and the statistical variable distribution, etc. So definitely we will be in touch with you.
Thank you again. Bye-bye.